Today we will be covering Lesson 11-1 on identifying arithmetic sequences. We will split this lesson into 3 separate sections. Questions 1 to 4, questions 5 and 6, and then we will wrap this up with questions 9 through 11. Let's go ahead and take a look at questions 1 to 4 together. It says use toothpicks to make the following models. So they have, and it's hard to tell on my copy, but it's got like a line. We have a toothpick here, toothpick here, toothpick here, 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 and here. Then here we have a toothpick, 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 toothpick. Here's another one, this one, this one. So it's like these two went kind of at the other corner, and then we've created this whole new box around it. Okay. And then we have the same thing, but this is at stage 3. Similar to that. Okay. So here for question 2, it says continue to stage 4 and stage 5 and draw your model below. So let's see if we can identify the pattern. So we're going to have 1, 2, 3, 4, 5. This is going to go up now. Then we're going to have 1, 2. We've got this other one to come in. So this is kind of like the beginning of 3, but now remember these two are going to come this way. And we're going to close out our box here. We're going to do the same thing with 5, but again, remember that these two are going to take an inward angle. So we're going to go. This one comes in. This one comes in. This one comes in. Now this is 1, 2, 3. Now we're going to come back in again. So this one's going to kind of move here. This one's going to move here. And then we finish out this box. After we lay these toothpicks out in this type of manner, it says complete the table for the number of toothpicks used for each stage of the models up through stage 5. So how many toothpicks were used here? Now recall that each one of these is an individual toothpick. So we have 1, 2, 3, 4, 5, 6, 7. There were 8 toothpicks at level 1 or stage 1. Let's count stage 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 of them at stage 2. Now I'm drawing those little lines through them to indicate that I've counted the line. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Let's take a look at stage 4. I'm going to cross through. Let's count as we go along, right? I counted 26. Going to do the same thing for stage 5. I counted 32. Let's take a look at what question number 4 on the next page states. Sorry, trying to grab my paper here. It says, motto with mathematics, use the following grid to make a graph of the data in the table. So at stage 1, we had 8 toothpicks. Well, 8 is somewhere between 5 and 10, closer to 10, right? So I'm going to kind of put it right there. Then it says at stage 2, we have 14. That's like really close to 15, but not quite 15, right? Then we have at stage 3, I had 20. That's at that crosshair, meaning where the two lines intersect. Then we've got stage 4 had 26. That's a little bit above 25. And then stage 5 had 32. That's not quite at the halfway mark, but close to. Is your graph discrete or continuous? And explain. So could I connect these dots with a line? That's the question. The answer here would be no. We can have part of a toothpick, but I cannot have part of a stage. Because remember, my X's represented stage 1, stage 2, stage 3, and so on. So no. Sorry. Graph discrete. Because you cannot have part of a stage. Is your graph the graph of a linear function? Now, is this linear? Yes. Even though we have a discrete data, we can still have linear, meaning that it increases by the same number or decreases by the same number each time. So yes, the graph is linear. Because it increases by the same number each time. Or if I would have said these all lie on the same line. I'm going to put a little note over here. All lie on a line. On to our debriefing for this section.